Okay, for example 5, we need to simplify each one of these and use radical notation for your final answer. Now you might be thinking to yourself, okay, great, we have radical notation already, but we have this little word up here, and that's simplify. So if we simplify this first, there's a couple different ways you can do this. With these relatively simple ones, like over here on the left-hand side, it might be beneficial to rewrite this as just one whole big radical. With part B over here, I'm gonna show you a different method, and we'll see which one that you like better. So if we go ahead and we write this as one big radical sign, we can just take everything underneath and multiply it. Now x squared times x to the third, we're going to add those exponents together, so that's x to the fifth power. And then y to the third times y to the fourth would be y to the seventh power. If we think about this, we've got 5 x's being multiplied underneath. So how many pairs of x's underneath there? And we're dealing with the square root here. Well, that would be a 2 pair of x's. And how many is left over? Well, that's 1. So 5 divided by 2 is 2 and 1/2. So the whole number comes outside, and then this will be x to the first. Y to the seventh power, 7 divided by 2, there's definitely going to be 1 left over. 7 divided by 2, well, that's 3.5. So then the 3 will be outside of the radical sign. And that's really all that you need to do. If you really wanted to, you could write this whole thing out. You could write out 5 x's and 7 y's, circle the pairs like we did in our previous example, and pull out what you can. That's okay to do, but you want to strive to kind of get a little bit faster at this, and notice that, hey, if you take 5 divided by 2, that's 2 and 1, and then the half part, or the denominator, is going to be out here. And then the 7 divided by 2 is 3.5. So the 1 will be here, and of course the 2 is what our radical is. So this is your final answer. That's fully simplified. Make sure that when you write it in this stage of the game that you see if you can pull anything out. And if you can, you should. For part B over here, it's a little more complicated. And I'm going to show you maybe a different way to deal with this. And so this different way is to take everything that's underneath the radical sign here. Remember, this is a fourth root. And we're going to change this into rational exponent notation. So remember, to do that, we need to take 64, which is to the first power, and write it as 1 over 4. Remember, if there is no exponent for a base, go ahead and write a 1. This fourth root, the 4, will appear in the denominators of all of these numbers on the right-hand side. So y to the 5 over 4, and this is going to be z to the 14 over 4. At this step, even though it might seem that it would be nice to simplify some of these, we're only going to simplify ones that work out to be whole numbers. And also, we need to take a look at this 64. To rewrite 64, that can be rewritten as 2 to the 6th power. Okay, x to the 8 over 4, let's go ahead and do that. That's x squared. Y to the 5 over 4, we're going to leave just as 5 over 4. And then z to the 14 over 4, we're going to leave it just as that right now. Okay, with this first one right here, this is going to be 6 over 4. We could write that, if we wanted to, as negative 3 times 2 to the 6 over 4. X squared, y to the 5 over 4, and z to the 14 over 4. Now at this stage, you can see that we have a 4 here, and the 4 is not going to go evenly into some of these. So we will have a fourth root. We will have some things left underneath. The ones that will come outside, we've got a negative 3. We've got a 2 to the 6 over 4. Now 6 over 4 is 1, so if we do like 6 divided by 4, that is 1 and 2 over 4, a remainder of 2. Keep in mind, we don't want to change this to 1/2, because then we'll have to change that to a square root, and not all of these might work out to be a square root, so just keep that denominator of 4. So the 2 to the first power will come outside, and then 2 to the second power will stay inside. Okay, the whole number, that can come out, and then the whatever the numerator is of the fraction, that's the fraction part of the mixed number, that will stay inside as an exponent. The x squared is good. There's no fraction, so it's going to come out. And then we've got a y to the 5 over 4. Well, 5 over 4 is 1 1/4. So 1y can come out, and 1y to the first needs to stay inside. And I'll put the 1 there for right now. We'll clean it up here shortly. And then if we take a look at this 14 over 4, that is 3 2/4. Let's just make it double. Let's double check that here. 3 times 4 is 12, and 12 plus 2 is 14, so that's good. So actually, a z to the third will come out. Remember, the whole number comes out, and then a 2 needs to be inside the radical sign. We're going to clean this up over here. Negative 3 times 2 is negative 6. You've got an x squared, a y, and a z to the third power. Fourth root of 2 squared, which is 4, y, and z squared. If you look underneath here, yeah, we changed the 2 squared into a 4, but this 2, this 1, and this 2 are all less than 4, and that should be the case. If you ever have a number here like maybe a 7, well, 7 divided by 4 is 1 3 over 4, or 1 3/4, so pull the 1 out as an exponent and make sure you write your base and exponent on the outside. This would be your final fully simplified solution, again using rational exponent notation and then changing it back into radical notation.